The world of industrial automation is getting more complex and integrated. Whether your needs are related to production operations, data monitoring, integration with smart cities, distributed operations, mining operations, roaming users, or remote sites, in this video we will explore how Wonderware offers an effective means of integrating this information in a simple, cost-effective manner, leveraging today's connected world. Let's see how we can do that. Today we'll be talking about Wonderware OI Gateway and MQTT, another one of those Internet of Things protocols. Specifically, we want to show the use case of how to bring data from the Internet of Things devices out in the field into Wonderware system platform and a control room. Let's start by showing how to leverage the OI Gateway to do this. In our new configuration, we have a way to create an MQTT connection to a broker. We actually also have a test broker, mqtt.iot.wonderware.com, and as soon as you create it, you can actually validate the connectivity there. We also give you secure connection. By default, the unsecured port is 1883, but if you want to try with secure connection, you can do so. Now the next step is just to enable that group connection, similar to the scan groups in other connectivities. And that's all you need for the configuration of the OI Gateway. Next, we go to System Platform, and I have prepared a little bit of it. First and foremost, I have prepared my derived templates, and now I'm going to create the template specifically for our well pump connectivity. In this template, I'm creating 3 data sets. I'm going to be monitoring the flow rate, the inlet pressure, and the outlet pressure. One thing to notice here is that MQTT is case sensitive, so pay close attention when you're using lowercase or uppercase syntax in your connectivity. Very important. And I'm going to also be leveraging I/O auto assignment functionality in App Server. So as you notice, I'm only enabling the I/O. I don't need to edit it because I'm going to be leveraging I/O auto assignment. Now that I have created the template, all I need to create is my instance. And as I walk you through this, I'm going to show you a couple of things that people typically tend to fail when using I/O auto assignment as part of this workflow. So first and foremost, we need to create the connectivity client to the OI Gateway. In this case, we're using the DDE SweetLink client and configuring the same as we created there, and using MQTT_G1 as the scan group as we created in the OI Gateway. Now that that is done, we can see that the gateway shows up in our I/O devices view. Keep in mind that in this particular case, I could not assign the area, which is what I want to do by default, so that my objects get assigned to it. So I have to undeploy the area which I already had prepared. So that's just to show you that pay attention to those little things when using I/O auto assignment. Now I can assign my device to the area, and because the area is already assigned to the gateway, it is there by default. Similar with my second instance, it's ready for I/O auto assignment. Our next step is to check connectivity. As you can see here, I couldn't do it because my proxy is not deployed. So once I deploy my gateway, I'll be able to use that because the gateway is necessary to check the connectivity to the end device. In this particular case, the MQTT broker. Now that I have been able to validate that, then I can deploy my devices and make sure that and validate that they're running properly in runtime. As you can see here, the connectivity to the MQTT broker has been established. In closing, we have demonstrated how the OI Gateway can be a very effective yet cost-efficient mechanism to address the Internet of Things related implementations. Thanks for watching.